Proof. Counterexamples, contradiction, existence, uniqueness. Vocabulary. Disprove, counterexample, proof by contradiction, contradiction, existence proof, existence theorem, unique. To disprove the statement, for all x in S, P of x implies Q of x, we find a counterexample which makes its negation true. The negation is not for all x in S, P implies Q of x, is logically equivalent to there exists x in S such that not of P implies Q, which is logically equivalent to there exists x in S such that P of x and not Q. So we look for an element x in S for which P of x is true and Q of x is false. To prove the implication P implies Q, we may use a proof by contradiction, which means assuming the negation of the implication and deriving a contradiction. The negation is not P implies Q is logically equivalent to P and not Q. So we assume to the contrary that P of x is true and Q of x is false. Our aim is to obtain a contradiction. That is, something will go wrong. To prove, the real number square root 2 is irrational. Strategy, a proof by contradiction where we assume that square root 2 is rational. Proof, assume to the contrary that square root 2 is rational. Then, where a be element of integer and b not equal to 0, square root 2 equals a over b. We could also assume that the fraction a over b is in lowest terms. From here, 2 equals a squared over b squared. 2b squared equals a squared. Since b squared is an integer, a squared is even. And a squared is even if and only if a is even. So, where c element of integer, a equals 2c. From here, 2b squared equals 2c squared. 2b squared equals 4c squared. B squared equals 2c squared. Since c squared is an integer, b squared is even. And b squared is even if and only if b is even. So, where d element of integer, b equals 2d. Then, square root 2 equals a over b equals 2c over 2d equals c over d. But we had assumed that a over b was in lowest terms. However, a over b couldn't be in lowest terms since both a and b are even, and therefore have the common divisor of 2. This is a contradiction. An existence proof is a proof of an existence theorem. There exists x in S such that R of x. We need to find some x in S such that R of x is true. To disprove an existence statement, we use its negation, not there exists x in S such that R of x is logically equivalent to for all x in S, not R of x. So we would have to show that R of x is false for every x in S. An element x in S satisfying a property R of x is unique if it is the only element of S with that property. Usually, To prove uniqueness, we show that whenever two elements A, B, and S both satisfy R, they must be equal. Using a direct proof, we assume that A, B, and S both satisfy R and show that A equals B. Using a proof by contradiction, we assume that 1. A, B, and S both satisfy R, and that 2. A does not equal B.